Hi, my name is John McFetrich, and this tutorial is on JavaScript, and it's going to be orientated towards C# developers. The Build conference occurred about a week ago, and the Windows world has been laid out for probably the next decade. A significant part of this will be able to use JavaScript for writing these Metro-style applications, something which I will be developing a series of articles on. But this tutorial, I'm going to try in an hour or less to cover most of the significant features of the scripting language. And may seem a daunting task, however, I think is quite doable. So we're going to get started in a little bit of history on the language. Now, I'm going to draw a lot from references here. One is going to be on Douglas Crockford's Most Excellent series here. The first one he did a series of 3 articles on JavaScript, or actually videos on JavaScript, and the other 2 came from the Mix conference that was held in last April. Just as a little bit of background history here, JavaScript started with Netscape days, so we're going back to the late to mid 90s, and the goal was to be able to put interactivity back into the browser. And one of the goals was to make it similar to a language called HyperCard, which made Macintosh. At that time, Apple was, as today, was being held out as probably being the best UI and ease of use. And HyperCard made programming very easy in this environment. So the team was brought together. I think they were still up in Chicago before they moved out to the West Coast. And they decided to combine the ideas of 3 languages. One, Java, then Scheme, which was a dialect of Lisp, and Self, a language which came out of that was Xerox PARC. Of course, Xerox PARC, Self is another example of things that were developed at Xerox PARC and really Xerox didn't do a lot with. However, for all reading I've done, it was a very good language, and probably should have been the one used instead of JavaScript. And from these 3, they produced what was called LiveScript. However, a little bit of politics got involved here, as usual. As Sun and Netscape were partnering against Microsoft in those days, and Microsoft was getting a little nervous that these guys may be able to pull it off and move applications more into the browser. And Sun wanted Java in the browser, though. They wanted to be able to program natively in Java, and they wanted to kill LiveScript. And the relationship, as a result, nearly broke up. At this time, Mark Andreessen, who was one of the keys behind Netscape, suggested, quite mockingly, that the name be changed to JavaScript. And this seemed to pacify at Sun. And so the name stuck. However, one thing that we've got to realize, there really isn't much in common with Java. JavaScript is the distinct language which is built upon those on the 2 others as much as Java. However, this didn't stop Sun from claiming the ownership of the trademark. And Microsoft at this time was, as I said, was getting a little nervous, and they looked at JavaScript, and they, of course, because Sun had taken out the patent on it, they reverse engineered it, and they reverse engineered it so well they even replicated a lot of the faults in the language, and they produced something which is called JScript, because they couldn't use the term JavaScript. Netscape then wanted to make JavaScript a standard, and they looked all around and they couldn't find anybody who would really want to work with them, until they found the European Computer Manufacturers Association, which showed some interest. And thus, one of the names that referred to JavaScript became ECMAScript. and but of course JavaScript and JavaScript also apply. And at this point in history, most of the JavaScript browsers, the browsers are actually implementing what is called ES5. And actually, I'm sorry, 3, and with 5 on the way. In fact, many, including IE9 and the most recent Firefoxes, are implementing ES5. So when you see the term ES, that really stands for ECMAScript. As a result, this is a summary. This language, and this took 2 weeks to develop. This is a pretty short time when it comes to any language. Because, for instance, Smalltalk took 8 years, and as a result, many of the bad parts were copied from Java. And of course, it was kind of like in the Bible where Java or C begat Java and Fortran begat C, and a lot of the style from these procedural languages was ported into some parts in JavaScript. And that's where we got the use of these semicolons and things like global variables. And one of the keys in this language was to make it easy for the beginner. But unfortunately, in doing that, it makes it harder for the professional developer. And the language itself has great expressive powers. However, you got to be careful because the bad parts, especially when you deal with things like the global variables, can be very dangerous. However, some organizations have been able to harness it with great success. For instance, the Google boys have been able to take and develop Gmail, which is actually rumored to have about 1 million lines of JavaScript. However, I'm not sure if that code was natively written because there are certainly tools in like Eclipse which let you write in Java and then have the JavaScript be generated. But I think the bottom line here is that the language was developed in only 2 weeks. So it is, and it does achieve the goal of being easy to use, easy to get started with. But as a result, it does suffer a little bit, and suffer in the things which a professional programmer would be looking for. And we'll go into these things later. Now, as a result, this language came out, and first it was only being used for adding simple interactivity to the browser. For instance, in this example here, we have an input button, and we have an on-click handler, and this all this is doing is putting up an alert box or a dialog box, and these things started to appear about 1996. The Outlook Web Access in '97 was a huge effort in JavaScript. And Gmail itself is composed of maybe up to 443,000 lines of JavaScript. And over time, the performance of Java got better and better as we started in 2001 as being the baseline and going up into 2010. So we're able to get a lot more performance from these engines in the browsers and thus much more robust JavaScript applications. Again, just as a reminder, the ECMAScript is another name for the JavaScript, and this is what we will see the term ESs. And 97 was the first version of ECMAScript. In 98, we got ECMAScript 2, and we were moving really fast. By 99, we had 3. However, 4, somewhere in between 99 and 2005, things slowed down. ECMAScript 4 was actually abandoned, and in 2009, ECMAScript 5 appeared, and it's being used in IE9, and we're evolving this further to the next version, which who knows when that the standards committee will release that. Now, the simplicity of JavaScript can be demonstrated by this slide here, which shows most of the key attributes of the language in one slide. And in this really is the part of the language. And let's just take a look at a few of the key attributes here. The language is similar to C, C Sharp, C++, C Sharp, Java, because it has things like objects, arrays, and functions. For instance, here we're showing an object literal where A is going to be equal to 10. We have our array, Y is going to be an array with values 1 and 2. And then we define our Z function. And we define that function directly in line here and using things like for ins, much the same as we would do in C Sharp, labels, and then we have fors, almost exactly the same as in C Sharp. So these things came from are showing it the heritage of C and Java, including the switch statements complete with cases. So I think it's pretty easy for us as C Sharp developers to wrap our minds around these things. We have while statements, ifs, and this we're familiar with, of course, in C Sharp. And it's slightly different, which we will go into later, and regular expressions. So the language, which was developed in 2 weeks, of course, had to be simple, and it is, because we're showing most of the aspects right here. We have now there's a small set of fundamental types. The integers, for example, there's only one type of number, and that is going to be our C Sharp double, which is 64-bit floating point. This really makes life easy in dealing with any kind of numbers, because we have no int32s, floats, and shorts, so we don't have to become concerned with number conversion issues. And built into the language are methods, because an int is an object, and we have methods like toString. We can easily add new functionality to integers or any object by just extending it. And for instance, we can add the trunk function. But, and here's one of the really big buts, we've got to take care not to override existing functionality. There are, in other namespaces, well, actually there are no namespaces, so other libraries. So, and this is a key difference with C Sharp, there are no namespaces. So you can bring in new functionality and extend these objects, but you have to be careful in namespaces. We'll go into that later. But these ints are first-class objects, so we have no need for things like boxing. And boxing in C Sharp is just we move things between the stack and the heap. And for instance, if we wrote something like this in C Sharp, we left off this cast on the mixed list, then C Sharp would complain. However, not JavaScript, so we don't have to worry about a lot of these issues. Another one of the fundamental types is a string, and again there's a lot of similarities here to C Sharp. A string is a sequence of 0 or more 16-bit Unicode characters, and each character is going to be 16 bits. However, in JavaScript there's no char as there is in C Sharp, and the way we get around this is just make a string that's one character, which certainly makes sense. Also, you can express literals with either single or double quotes, as in you can have either the double quotes around ABC or the single quotes, but we can't mix them. And like C Sharp, these are immutable. Now, here's we start to get into some interesting area here. I know in the vast difference between C Sharp and JavaScript is the var keyword and associated the type safety or lack of. Remember, JavaScript is a dynamic language. C Sharp with link does have some attributes of a functional language, and is LINQ lets us do things in kind of a functional way. However, JavaScript always has been from the start a dynamic language. And the var is the keyword that we use to define a variable or even a function. And for instance, if we define tt as being a var, then var we can equally assign var the value of 1, 2, 3, which is an integer or a string. And JavaScript doesn't care because there's no type safety, and only at runtime is the actual value known, or really doesn't care. So we can, on the fly, we can assign anything to TT, including make it into a function, such as we show here. Now, of course, in C# we also have a var keyword, but don't confuse this, because the var in C# is type safe, because it's we're going to take on the left side, whatever we have on the left side, var tt. In the case of 1, 2, 3, var would take on the type int, and because really in C# the term var means implicitly typed local variables. So its type depends upon whatever is being assigned to the variable. Another interesting point and source of confusion in JavaScript, particularly from C# point of view, is that there are many values that act falsies. For instance, false, null, undefined, an empty string, and 0, which kind of makes sense when you look at it from the point of view of C, where 0 was false and 1 was true, and not a number. Everything else, every other thing is truthy. So we've got to be careful in using these. So bearing this in mind is going to slightly change how we write code in JavaScript as opposed to equivalent in C#. For example, the following example we would do in C#, but not in JavaScript. If we want to test that a string is not null and has some characters that we may be interested in, we might do something like this, where we say if some string is not equal to null and some string dot length is greater than 0, then we've ensured that some string is not null and has some characters. Now, we can do the same thing, though, much simpler in JavaScript. Is we can simply write that if some string do something. And the reason is because undefined, null, and empty string are falsies. So it just makes our code a little simpler. Also, in C#, if we want to set a default value, we do something like this. We're going to assign some string a value. If some string is not null, we will assign it some string. Otherwise, we will set a default value. So this is a ternary expression. We don't have to. This becomes easier in JavaScript, because just to set a default value, all we need to do is check the object itself, because some string here will be falsish if it is null or empty. Now, the wrong comparison operators can cause some confusion here, and there is two sets of comparison operators, because if we're using the equal and not equal comparison operators, JavaScript tries to help you by coercing the two values into the same type. Now, this can lead to some confusing results, especially if you're looking at this from the point of view of a C# developer. For instance, a 0 will be equal to an empty string, because both of these are falsish. A 0 will be equal to the character 0, again because they're both falsish, and same if we're comparing false and the character 0. And also, probably the most surprising is null will be equal to undefined, because again, they're all falsish. The way around this is, if you want to maybe think, have your code and think more in C# terms, use the equal or the not equal operators, because these will not only check the value, but they'll also check the type. And the results of these comparisons are probably more what you would expect. So, for instance, in this case, our zero and an empty string will be false. Our 0 and the quoted string, the character 0 will be false, and the character 0 will be false, and null and undefined will be false. So this is probably more that you would expect from a C# point of view. JavaScript is an object-oriented language. It's we looked at the simple types, which are strings, are booleans, and numbers, and these are object-like in that they have methods and we can add methods. However, these are immutable. Everything else is an object, and an object in JavaScript is simply a dynamic collection of properties. And most importantly, these are class-free. This is different from C#, where an object is a class instance. And so these properties are bags, and each property has a key string. And then we have to wrap our minds around a thing called prototypical inheritance, which is different from the classical inheritance that most of us C# developers are used to. But we'll get more on this later. And of course, C# is all about classes, inheritance, and things like polymorphism and interfaces. You can kind of simulate some of these things, but they natively do not exist in JavaScript. The way we create these objects is we have these object literals, just these braces, and these are going to surround 0 or more name value pairs, and these name value pairs are much like we do in JSON. So, for example, if we want to create an empty object, it's just var empty object equals, and we just have our left and right squirrelies. And then we can define an object called name. Now, name is going to have two properties. One is going to be first name, which we're going to set to John, and last name, which we're going to set to McFetrich. By the way, these quotes are optional if the name is a legal JavaScript name. And of course, in this notation, we can also define a function here. We have upper, and in this case, the only thing we're doing is returning a string. It's also possible to embed these objects within objects. And for instance, we can have define this flight object. And it's going to have two properties, airline and number. And then it's going to have an embedded object, which is departure. And departure will have two properties, a city and a gate. Then if you then do a console.writeLine on flight.departure.gate, then of course we will pick up this value of 2. Now it's important to wrap your mind around this idea of prototype. It's the prototypical inheritance is one of the more controversial features of this language. Classical languages like C# were first formulated back as early as 1967. So they've been in existence. This classical form that most of us C# developers have been used to using. It's been around for a long time. The prototype school, what came out of a course, Xerox PARC, and it was part of that Smalltalk project. It came 20 years later. So, and many maintain this is an improvement. However, I think it's one of those things, it's a matter of taste. Certainly, it has, because we don't have things like inheritance, like interfaces, I think there are, in my opinion, some deficiencies. However, and the way you create these objects with it's just these literals, or they can create function. Prototype, just more on prototype, it's also referred to as differential inheritance, in which you make a new object and you just add stuff to it to make it different from the object that it inherits from. So the new object only contains the differences. And every object has a prototype attribute. Now, objects, of course, have prototypes. Just more on this. So if we define a var in object O1, it's just an empty object. And if we walk up here and we type in O1.value of, we will actually see that value of shows that this is an object. Now, where did this value of come from? It came from our O1 is going to inherit the object.prototype, and the object.prototype is part of the language, and it's going to have two functions, toString and value of. So the value of came from the object prototype that our O1 derives from. Now, if the property isn't in the current object and value of was not, then we went in and we checked this prototype. This is where we pick up the value of, and of course, this could lead to some strange results if because we don't anticipate going up this chain, and there's ways around that. And we can also override, because everything here is a function, we can override the value of function itself. And so we can define a new object, O2, and we're going to give it a value of, we're going to override the prototype, and we're going to give it our own function, which is just going to return the number 10. So it kind of looks like this, where we have their value of is going to, in our own object, is going to override that is found in the prototypical chain. Let's just look a little more at how objects can inherit from other objects. In this example, we're just going to create a new object, point 2D, and it's going to have two properties in x and y value. And these are properties in the object's property bag. And then we're going to call object.create. Now this is new in ES5. And in the past you had to do things like this with user-defined functions. With ES5 there is the create method. And so we're going to create this new point 3D object, and it's going to derive from point 2D. So, and then in point 3D, we're going to add this Z property and give it a value of 30. So the way this looks is that we have point 3D with its Z property, and then its prototype is point 2D, and of course it's going to share the X and Y properties of point 2D, and then it follow up the chain to the object.prototype. So I think you probably get the idea that objects inherit objects, not types, as they do in C#. Just a little more on this. We can create this new object called location, and we're gonna give it this name property, Mandalay Bay, and just again to show that point 3D and location are both sharing the x and y properties which were defined in 2D. So we were conserving memory. Now, objects in ES5, objects can have data properties and accessor properties. Much like, so we can have much kind of getters and setters, much the same as we do in C#. In the past, we would have like bank account is the object, and we have a balance property. But there was nothing we couldn't have an accessor like we did in C#. However, with ES5, we have an accessor property, which is defined with this defined property, which has been added to the JavaScript object. And here we can do we can define our get, which is simply going to return the balance, or our set, which will, like we do in C#, set the value. So we're intercepting the reads and writes and providing an optional setter. We also have what are called constructor functions. A constructor function expects to be used in conjunction with a new operator to construct objects. And for instance, and you usually, by convention, we usually call this we capitalize our constructor function object. And remember, functions are objects. And just by convention, so we can spot this easier. And in this case, we're going to define our constructor function is going to affect new up this object that'll contain an x and y properties, and then a method. And the method here is the add method, and it'll just add the input point to the x and y properties that are part of the object that we're newing up. So we're going to use this much the same as we would in C#. For instance, here we're just going to define our new object P1, which is a point 3 and 4, and P2, which is 8 and 6. And so if we call the add method on P1, then the result of x will be 11. Again, this should be much the same as we would do in C#. Now, I'm just going to show you one way to test these scripts. We can go into any IE instance, in this case IE9, any IE9 instance, and then under Tools, we can run this. We can run our console, or we can just under here there is under Developer Tools, or more simple, we can just hit the F12 key, and this will bring up our console. And in this console, we're able to type. Let's just clear this guy on top. We're just going to clear the console, and to so you don't have to watch me type. I'm just going to paste in the function that we just defined in that slide. And when we run this, we can now run this script in the contents of this console, and we just go run script. And down here, of course, it shows you the value of 11. So it's a nice little tool. Of course, there's no IntelliSense here. However, it's just nice to keep that in your bag of tricks. Now back to our slides. There's one slight problem with our simple and contrived example is that we've got this add method that's actually defined on both P1 and P2. So what we really want to do is to move that into our point.prototype so that both P1 and P2 objects are sharing the same definition of the add method. And the way we do this is we slightly change our code. So we're going to our point function is now only going to contain the x and y properties, and then to the prototype for point, we're going to define the add method. And so we move the function as we moved into points prototype. And this is just to save memory to make our code more efficient. Now, just a summary, of course, a C# class is different from a JavaScript object. In C#, we must define the class and then new up the object. And as we all know, we just define a class and give it our properties. And then use the new operator. But that new is much the same as we do with that constructor. However, we're dealing with objects in JavaScript, not classes. Now, the JavaScript and the Smalltalk people will argue that this C# and this also not just C# but C++ and Java. This template method is and this is what this is called, makes the structure of our pattern static and makes the derivatives of the hierarchy statically coupled to the base abstraction, and thus not as flexible. Well, it's like anything else, there are pros and cons. Because there's a huge downside. We have no native interfaces, no abstract classes, so it's much harder to implement things like factored patterns. But I just wanted to show you briefly here, again with objects, the way that we can retrieve the properties is, as we showed before, the flight.departure.gate, because it's like a bag. Now, but if we can, on the fly, we can add new properties. Time is not defined. We can add the time property on the fly because JavaScript, remember, is a dynamic language. And our values can be updated by assignment. And objects are passed by reference the same way that they are in C#. Yes, well, we couldn't avoid talking about functions in our discussion on objects, but in this section I just want to more formalize our discussion of functions, which happen to be the part that JavaScript probably did a really good job on. There are some parts of JavaScript that are a little dubious, but this part they did do a great job on. Other languages have methods, constructors, classes, but JavaScript only has a function that does all these. It is the word function with an optional name and parameters, and then the body, which is going to be wrapped in the squigglies. And this is going to produce a function object. Again, object. As an object, it is a first class object. It can be assigned to a variable, passed to an argument, and stored in any object. And like all other objects, mostly like all other objects, it inherits from a prototype. And in this case, so it is function.prototype. Now, the older form is a function statement, and it has a mandatory name, but it actually turns out to be a shorthand for a var with a function value. So if we write function foo, and with our curlies, this actually is going to be expanded to var foo equals function. And this in turn becomes turned into the following, where both are hoisted to the top of the function, or wherever they are if they're in the main body. We'll soon go into hoisting. It'll become very clear the importance of this term. So the var foo equals function actually gets turned into a var foo is undefined, and then foo equals the function foo. And these are, as I said, these are hoisted to the top of either the function they're in or the body, the main body. So we have an expression versus a statement. And if the first token is a function, then this is a function statement. Just a little, just more details here. These are first-class values. They can be defined with function declarations, as here, or they can be defined as anonymous function expressions, much like we would do in C# with our anonymous delegates. In this case here, sum2 is an anonymous function. And the name of the function is going to refer to the function value. Functions as first-class citizens, they can be passed around. So we can define a function wrap, which is going to take a parameter f, and then when we call wrap, we can pass in a anonymous function because it is just treated as a normal object. Just as a review, is kind of like, so these are kind of like in C# like a delegate, where in this case here we have our for each, and we're going to provide an anonymous delegate to the for each, and it's just going to do a console.write line, or probably most similar to the lambda expression where we write this in the following form. So there shouldn't be a lot new here. The var, though, we've shown var. I just want to formalize a little more about var and to also talk a little bit about the hoisting here. The var allows you to declare and initialize variables in a function. There are no types because this is a dynamic language and you can assign anything to that var. In the var, the variable is visible anywhere in the function. It is also broken down into two parts. The declaration part gets hoisted to the top of the function and is initialized with undefined. And the place where the original var statement was gets turned into an assignment statement so that the var gets removed. So if we have, just to be more specific, if we have a var, my var equals O, it will expand. This will be expanded to var, my var is undefined, and this is hoisted to the top of our function. And then the my var equals O is going to be left at its original place, wherever you defined it. This hoisting has a big implication when it comes to scope. In C#, we're used to dealing with a block scope, in which we define a variable as defined within the scope of the block. It's contained in. Not the case here. Due to hoisting, blocks do not have scope. Only functions do. So do not write. If you write something like this, where we got a function foo, and we've got a var of 4, where we have a var I, and then inside of this we have a var. We use that the var row equals matrix, and internally inside of that 4 we have a reuse of the var I. We're going to end up in an infinite loop. So the key here is with the block scope, declare all variables at the top, not near where they'll be used. In C# is probably more common to declare variables closer to where they're going to be used, and declare all functions before using them. Now, just to make this more concrete, I've got my function foo, and in here I have a block, and it's defined by this is true. In my block, I have a local variable. In C#, this would be local to this block of code. However, this is not the case in JavaScript. If I immediately call this nested function, inside a function, I also have access to that local variable. So in summary, it's a good takeaway is to make sure that you declare all your variables at the top of the function, not in place as they are in C#. Functions always have a return statement, and this can be either a return expression or simply return. And if there's no expression, then return is undefined, except in the case of constructors, in which case it will return this. And this is how we are able to new up new objects. Now, this is an important concept in JavaScript as it is in C#. In JavaScript, it's a reference to the object of invocation and allows the method to know what object it is concerned with. So this allows a function object to serve as many functions, and it's kind of a compile-time polymorphism. It also turns out to be the key to prototypical inheritance. Now, just an example how this works, let's say we have a function speak, and it takes a parameter text. And speak is really simple. It's simply going to output a adjective, which is a property of this, and plus whatever text was passed in. And then we'll just use console.log to pump that out. So and then we're going to define an object bill, and bill has this is where we define the adjective, and we'll call it bill, and then we're going to have a function here, speak, which is actually the speak function itself. And so in the case of this guy, this is bill, and then we're going to define another var Ted, where our adjective is Ted, and so this will be Ted. So if we go down here and we type and we say bill.speak and we pass in hi from bill, then we will see this is bill, because of course this function speak is being executed in the context of bill. This is bill. And in the case of Ted, this is Ted. Now, just to make this hopefully a little more clear, there are special rules for this. Let's define. We have an object, and this object defines a sum function. And sum will just take and add together two numbers, and we can call this simply by calling the .sum method on our object, and the calls on the receiver object are going to look like method calls. Or within this object, we can define a local variable offset. And offset will have the value 7. And we're going to change our function slightly to return x plus y plus offset. And so inside a function, this is going to be bound to the receiver of the call, if there is one. And in this case, when we write sum 3, 4, then we're going to be, this is going to be bound to object 2, and we do have offset defined as 7. So our result becomes 14. Now, if we execute this outside in the main body, and we just define a var f equals obj2.sum, unfortunately, this is the global object, and this .offset is undefined. So we get an unexpected result. Now, just as a fun little example of how to tie together most of this stuff, I've got this, I put together this little sample here. We'll just running in Visual Studio, and of course it comes up in the wrong monitor. And it's just an HTML5 gradient on a canvas, and I'm just going to show you how this was built using some of the concepts that we have been discussing. And this is kind of I think a fun little example. In this case, I've used Visual Studio itself, and I just defined my JavaScript in the script tag. I've got a canvas element here, and first thing I do is I get, of course, my var here is the canvas object, and I'm getting the element by tag name, and I'm picking up the canvas. Now I could have used jQuery, but this is a pretty simple example. And then I get the 2D context for our canvas. The next code was I just had left over from another example where I'm actually showing the use of a setter. And if you indeed put a breakpoint right here, this will be called whenever we say foobar equals 5, the same way it would in C#. But back to our real example here, what I define is a radial base, and this object is a radial base, and it's going to be newed up. Notice it has the capital R, so it's a constructor, and we're going to pass in the canvas, the context, the color, and and the X and Y positions and the width. And we're just going to set these properties on this object. And then we're going to show in fact, I call the method show. I'm going to add to the radial base prototype, and this function is going to clear the context, or clear the rectangle, and save that new context. Create the radial gradient right here, and then we're going to get the colors. We're going to call a function here that'll get the colors for the gradient, and we're going to set this and then set the fill style to gradient, and then fill the rectangle, and save away our new context. And the get colors simply does as advertised. It's another function on the redial base, and we're going to set the colors for our gradient. And we just invoked this with a new, because this was a constructor, radial base, and give it the required parameters. Then we call the show method, and as a result, and the nice thing, of course, in here is because we've got not only full IntelliSense, we got full debugging, so I can just run to these breakpoints and take a look around. Here is the breakpoint on the setter right here. So, and then we're just going to move this guy. And then we're down here in the get colors. Look at the call stack. We see how we got there. We're in it was from show, and we're going to set the color stops, and then we're going to go back up. And so one of the big problems, of course, in JavaScript is that everything's global, or it's at least going to be have a function scope. So it's particularly globals can become very nasty because we can collide with a similarly named object or whatever from a third-party library that we pull in. jQuery does a good job of protecting this, and however, not everybody does. So it's easy to do name collisions because we don't really have namespaces, as we have in C#. Now there are ways around this, or ways of mitigating this damage. And however, this I think will show some of the advantages of C#, because we can do things like this, where we define pan is going to become our namespace, because we're going to wrap all our variables are going to be wrapped in this pan object. And for instance, we will have a type which is fry, and then we're going to have a function which is fry, defined with this object literal. Now we can use this namespace pan, So if we're quite safely, and we have absolutely no problem with namespace and collision with variable collision, we can use console.log pan.type. And in fact, we can even take and we can add a new property on the fly. However, the big problem is all these vars are public. So, and of course, in C#, this is so natural and so simple because we just have our private and public and protected properties. I think, and this shows you can do this stuff, but it becomes much more difficult. And as another example of the level that you can go to and the complexity it can add, here's another solution here, where we use what's called a self-executing anonymous function. That's a mouthful, and this is going to give us private and public variables, but the complexity is, I think, fairly onerous. And here we're going to define a game pan, and the red parentheses turn this function into a self-executing anonymous function, meaning it's going to be executed immediately. And in here we're going to define this public property. They call it public, and then we have this grease, which becomes a private property we can only access within this function. And we can set a property on public, set it to bacon, and this will be returned by our function. So down below here, we can access the public property as normal. However, I think you would agree that C# in this case is way simpler. The last topic that we're going to look at is closures, or as they are often referred to as nested functions. We'll try a couple of explanations here because it's not always so obvious. Number one, we'll describe that the context of the inner function includes the scope of the outer. The inner function has the context even after the parent function has returned. Now, if this doesn't make sense, let's try the following. It's a special object that combines a function and the environment in which it was created, including any local variables in scope at the time the closure was created. Now, I hope that one of these makes sense. If it doesn't, let's just go through a couple of examples to clarify this here. In number one, we're going to define this makeAttr function. And it's going to take a parameter, and it's going to immediately return an inner function, and which is going to take a parameter and return the sum of two variables. Now, and when we use this is we define a new function object, add 5. It's going to be equal to makeAttr, and in this case, we're going to pass it in the number 5. Well, in this case, that 5 is going to be captured. And then when we go to a console.log, add 5, and we pass in a parameter 6, well, we've captured 5. So the result will be 11. Now, let's just try another example here. We'll use closure to solve a real kind of a simulated problem. We've defined this little method where we have a var of names, and names is an array of strings, and then we have digit name, which is just going to be a function that's going to return one of these names. And if we do an alert and pass in the parameter 2, of course we will get 2 returned because we're indexing into the array. However, this, of course, is really bad because all the names are global. So we decide, oh, we've been looking at this video and say, oh, globals are not so good. So what we do is we go when we define, we move the names, we move into the function. And this is a pretty simple move, but it's much better because the names is no longer global. However, if this happened to be repeated many, many times, thousands of times, this could be a little inefficient. So we use closure to solve the problem. And we define this new function object digit name, and it's another one of these. It's going to be another one of these self-executing anonymous functions, and we move our names into the function, and when we return a return here, names is going to be names will be available because names will be captured. So the digit name is the return function and not the whole function, and has access to names even though the odor is already returned. We reached the end of my video, and hopefully this has given you some idea on how to use JavaScript. This is never intended to be a polished video. It's only gives you it's kind of a guide. Hopefully it's going to give you some assistance, and it's going to be the basis of some of the talks I will be giving at the code camps. A lot of the material, of course, came right out of Douglas Crawford's book, JavaScript, the good parts, and the other two videos which is shown right here, which were the Channel 9 videos, which were from the Mix conference that was held last April. Thank you.